through. Awesome. Yeah, sorry, John, you were talking about Lara's 2.3 trip?
Yeah. So just talking, she's going to Banks Peninsula. There's a talk by a ranger. And at the Holswell Quarry, they talk through the series of eruptions and the rock types, and they collect basalt and scoria. So I guess perhaps we're talking about that's a lot of geology. And then they do field trips to the Antarctic Centre, and also they go to Quake City for a liquefaction study. So I guess that's a really, really great set of trips that they're doing. So 3 trips for a Year 12 class is pretty busy. So my congrats on that one, Lara. That's I'm not sure I could maintain that effort myself. So, but you've got this comment here that you don't know how to organise them, or don't know how to organise something more adventurous. So, where are we kind of going with this?
I mean, it sounds, Lara, like what you're doing certainly has strong links to a lot of those level 2 Earth and space science standards, and making it more adventurous. I mean, I guess we can talk about some field skills and things like that might give the students a bit more purpose on the trip, rather than just collecting a rock or being spoken to. But, from what I'm hearing, you're doing a great job of getting the students out already. And I guess if you're new to ESS, it's just going to take a little bit more time to feel comfortable. And, the adventurous side of it, while earth science and eruptions and all of that, pretty amazing. The more adventurous you're thinking, the more health and safety and risks that I guess you're drawing into the trip. So, yeah. And, but yeah, awesome that, having been to Quake City and the Antarctic Centre in the last couple of months, you're lucky you've got those facilities, and while not amazing from a student perspective, there's still certainly a lot of learning that would be done on those trips. So from my perspective, you're still doing a great job there.
Yeah, and Lara came back and said, "Look," so Lara came back and said she don't think more adventurous was her comment. So perhaps not looking at taking them out in the bush for a week or something like that. But to be honest, I don't think anybody's going to expect you to do anything outside your comfort zone. And certainly, I don't think, if you're new to Earth and space science, the planning and the organisation and the confidence takes some time to develop. It's not instinctive in anybody. I can assure you of that.
Mm. And we talked earlier about trust, but honesty is a big thing too. If you don't feel comfortable taking the trip, you just got to be straight up and I guess let your head of faculty or your senior members know, because if you're lacking the confidence to run it well, that's when things will go wrong. And I'd hope they understand that. Not everything has to be a field trip. We're just trying to push the right type of field trips today. But yeah. Maybe when I cut out, you managed to talk a little bit further on data and evidence, John.
Okay. Well, there's just another comment come through from. She said, "I find the students need to have some local context. A lot of the students had very rich experiences previously." Okay, so you're in Christchurch. Do you have an estuary or a river nearby, Lara?
There's tons of rivers.
Yeah. But particularly an estuary, if you can get to an estuary, there's something. Okay, so for level 2, you have your earth hazards, but you also have your earth systems. And estuaries seem to be a really, really interesting junction of a whole bunch of earth spheres. So I don't know if I think down there you don't have mangroves, it's too cold, but you've got all sorts of grasses and all kinds of very, very developed plants that and animals that function around those boundaries between the earth and between the sea and the freshwater, and so that they're all very, very interesting things, and they've got tremendous levels of adaptation. So, for example, going to an estuary is actually a really, really interesting place. Perhaps you could do, with your extremophiles assessment, you
could get to a cave. Yes. Even I know there's a few caves around.
Yeah. So but particularly estuaries. Estuaries are really, really good, and particularly because with estuaries you've got all those very, very fine muds. You've got anaerobic and aerobic conditions going on. So that kind of stuff is really, really interesting and massively overlooked in our teaching. Like, we tend to teach about nice shiny beaches, we talk about mountains, and we don't talk about the muddy, sticky stuff that is very, very cool.
And that's great getting your students out there and a bit dirty too, because if they head into earth science, that's somewhat going to be their life.
Yeah. So I guess you do love a bit of mud. Yeah, and the particular thing with with estuaries, of course, is that you have that mix of aerobic and anaerobic conditions. And of course, they're also a really, really big indicator of the effects of global warming with inundation and things like that. And particularly with mangroves, they're really, really good at smoothing out surges and things like that, which can be highly destructive to the inland structures behind them. So that's it's a good place to go, and if you want to go and play with the mud, I'd highly recommend it. And kids really love getting muddy. Sorry?
Take a few cores of the mud.
Yep. Yeah. Now, one of the things we do is when we go on these field trips, particularly with my year 13s, but year 12s can do it because we do it with the 2.1s. We basically say, if you want to write a report about something, then develop your own equipment. So, for example, the kids make up transects. They, get PhD meters or temperature profiles, that kind of stuff. We just say, look, you're big kids, go out and work out how to do it yourself. So once you've got a few field trips and the kids have got a bit of experience, then getting them to actually design an experiment and go and test it is a really, really rewarding experience for a lot of those kids.
And that's what you want them doing in the level 3 standards as well, taking more ownership of investigative approaches rather than, here we're going to do this and answer all this and blah, blah, blah. Yeah.
Yeah. And I don't know what your school budget's like, but there is some absolutely amazing stuff like Pasco, where you can do all manner of testing very, very effectively. And I would just look at that. It's fantastic stuff. A lot of it uploads information wirelessly to your phones. Okay. What investigations would be good in an estuary? Let's go through. Ross, we'll put you on the spot first, mate.
Typically don't go to the estuaries, John, but you could certainly look at mud content present. Again, bring some mud back to the classroom and explore it a little bit further in subsequent lessons. I mean, I know earth science, we want to stay away from the biology, but you can also look at what's living around in the estuary as well. There's good connections to the, I guess brackish would be the right term, but the fresh and saltwater interface. How does that change? Or maybe if you've gone at high tide or a receding tide, you can see what changes as it goes out. A lot of observation, I would say. But yeah, John, you're a bit more of an estuary theme, don't you?
Okay, so we do a river investigation, and things that we would investigate in the river are things like temperature, pH, nitrate concentrations,
Water
and by
clarity.
the way, yeah, water clarity is a good one. Conductivity is a really good investigation, and that is going to change with time, but it's also going to change with location in an estuary. You could do grain size. So as you go down the estuary, the grain size will get smaller and smaller and smaller. And Ross, you might want to discuss this, perhaps you know more than I do, but when clays go down fresh water and hit salt water, they become insoluble and precipitate out. So there is an area in the estuary where you will suddenly find very, very fine grained clays, and that kind of indicates to you where the load of the river is actually being deposited. So that would be quite a good one. Another one is temperature. So with water going in and out, you're going to have not only a change in salinity, but a change in temperature. And you can relate that to the buoyancy of the water. Because, of course, cold, salty water is going to sink. Warm, fresh water is going to rise. So that's actually quite a good little thing to measure. Another one you could look at is how far the vegetation is from the high water mark, because that tells you where the salt gets to. So there's all sorts of investigations there. There is also, you could measure atmospheric CO2, for example, and see if that changes with location. There's so many things. Some of them are not going to give you results. But for example, there's a chap up in Whitianga who has been he's made these buoys that he throws out and does all sorts of interesting measurements. And his kids have written academic papers with the results, that things that have never been observed before. And so that's really, really interesting stuff that you can discuss. You may find that from time to time you get CO2 coming down the hills or whatever, or it may change with time quite considerably, and you can measure that. And every room in New Zealand at a school during COVID had a CO2 meter, so these things are not expensive. Nitrate measurements is a big one, particularly if you've got a farm nearby. But there are nitrate measurements and there are nitrate measurements, and you need to make sure you've got the right one for what you're measuring, because we went out and did an assessment one year and we got absolutely zero results, and it turned out the water was quite polluted, but we were using the wrong measurements. So like those kinds of things. And you know what, here's a chance for you to find out stuff that you are interested in and get the kids to do the work. And now we've all wanted to be a supervisor in an academic program.
I've certainly as well. A lot of the standards talk about secondary data. So like if you've got your kids out there doing busy hands-on stuff where you collect a lot of data, if it's not entirely what you want to get out of it, you can always go back to what experts have found at a range of other sites and do some comparative work. So I'll talk to that pretty soon. I will move on a bit. I know my connection issue cost us a bit of time there. But a few things about making it count. So what should you do as an educator at your site? First of all, your site suitability or pre-visit. It should give you the chance to actually, learn a lot about your site. You don't want to turn up not knowing anything. At times in the classroom that can happen, but it's a lot easier to be honest about that there. If you've taken all the kids out the school for the day and you're really not sure what you're looking for or what you're looking at, then, you do look a little bit silly. So you want to be a bit of an expert on the site. But another great thing to be doing is use it, inquiry prompts, not being too leading with your students, giving them a chance to think properly about what's there. before giving them a bit more of a helping hand. Another key thing is what your tauira or your student should be doing. And John's just rattled off a whole range of different data collection techniques they could do. But, you could assign them roles at site. They could be responsible for each other's health and safety at times if you trust them enough. Someone can be the data recorder, all those things that you would do in a classroom to try and engage the learners, they can also be happening outside as well. The skills and capability, I'm going to talk about that now. But, if you think about from an earth science perspective, interpreting and reading maps, that can start in the classroom before you get out there. Students could be using a compass for strike and dip, identifying and describing rocks. It sounds like you're already doing a good job of that, Lara. Measuring sediment size is something John mentioned in an estuary. Another big one, taking labelled photos or appropriate field sketches. And, John's mentioned wireless or using Google Sheets or just a field notebook. All of those things count. Considerations for that, though. Have you got a booklet printed? What do you want them answering? Some students need a bit more of a helping hand. Have you got GPS or your cameras? What chemicals and tools? John, I'm glad you spoke about measuring. You must have been looking at nitrites rather than nitrates. I think someone at our school's done that in the past too. You just need the right water testing chemicals, which I'm sure your lab technician at school can easily organise. But again, have a trial run in the classroom. Fabricate some samples and see can the students use it correctly before you get out there and let them run loose. A couple of other key things: water, you're outside, sunscreen, pencils and clipboards, all of that stuff needs considered before you get out there. And I guess, John, with your wireless data transmitters, or if you're using Google Sheets or something, do just keep in mind that occasionally when you're going on an earth science trip, you might not actually have any cell reception. So check the things are going to work before you get out there.
That's a very good point.
Oh, yeah.
Sorry.
You go.
We deliberately go to a place where there is no cell phone reception and no internet. And so that forces the kids to go back to using, basic methods of recording data. And particularly, they can't use GPS to put themselves on the ground and work out where they are. So when they go back to school, they have to actually use maps and write down coordinates from maps. So we find that's actually quite useful. The other thing we do is we get the kids, they relate their data to someone else's data using a bivariate analysis. And although we haven't done it this year, next year, they will be using that as a submission to get some statistics standards as well. So for a lot of boys, that's going to be quite, or a lot of our kids, it's a boys' school, that's going to be very, very useful for them in terms of making sure they get the credits they need in some cases.
Awesome. Now, what we're looking at here, I just grabbed a couple of examples from some field booklets or work that my students have done at some sites. On the right-hand side here, I certainly had to talk about keys in advance of going to site, but you can see here a sketch that a student's done, which is pretty phenomenal, using a key of a specific site that we study for a level 3 standard. On the left-hand side, I talked about somewhat using inquiring questions. You can sort of see stock 2, we've taken them up one of the many maunga or volcanoes here in Auckland. Nice, easy leading question initially, but then a why question afterwards. I wouldn't ever tell them the answer to this initially. I'd get them to think about it for a while first. Obviously, we move on to stop 3, and then rather than showing, this is a grass-covered mountain we're on, I've just said, find a lava bomb. The students have got to go through knee-high grass, having a search everywhere. It's a lot better than just saying, oh, come over here and see this lava bomb. Let them explore at the site where applicable. I've also got them trying another little skill there, drawing a scale to show its actual size. I'll make this one quick. It was going to just be a little activity to sort of apply our learning. and Lara, this will be probably a very unfamiliar location for you. You can see down the bottom here, I've indicated a place called Wigmore Bay. I've just said, you've heard from another teacher, there's a good outcrop of volcanic rocks at Wigmore Bay. You get approval to go next week, and you're going to take 40 students with you. Here's a bit more of a close-up, so right down the bottom, a bit of a zoom in, and I've just said, identify 2 features that make this a strong site for fieldwork, and then assess the suitability. John, you're probably a bit more familiar with Bethells. Give us a quick breakdown on the suitability of going there.
One of the issues you've got there is you've got very, very steep slopes around it.
Yeah.
It's extremely remote. The surf is extremely dangerous, and the rock is kind of unstable. So if you get anybody crawling around on that rock, you're in trouble.
Perfect, John. It's like you've been there on a trip before. I just had a few things to run down. Would you go on this trip? No is my answer.
No.
And, number one reason, you've heard about it. You haven't been. It's next week. You've got no time to prepare. Likely access issues. John nailed it quickly. You're a good couple of kilometres walking along a dangerous surf beach, which makes it not ideal. You've got big waves. You've got unstable rocks. So there's a whole lot of critical health and safety. Also, checking out the tides to get there. And another potential too, if you're looking at this map, the roads end well short of it. You're going to be crossing private land. Whole range of things that in a week's time, it's just too much to go ahead and do. Certainly would be assessment opportunities there and a wide range of them. But, that's not enough to just throw the kids in the bus. And I think I mentioned 40 of them. That's two bus loads, probably 4 or 5 teachers. It's an expensive trip for not knowing a lot. I also mentioned too, could we include another learning area? Like we all know geography go on field trips, biology too. If there's a site that's nearby that, they could tag team, share the costs is a great way of reducing your cost and also giving other students in the school a chance to get out there. But yeah, I'm glad we're both on the no there. So just on to a bringing it back to the classroom. We've talked too much about cost, I think. This is all about reflection, by the way. Did you achieve what you wanted to on the trip? And, did the students actually have a good time on the day? So I guess, being out of class, and your classes too, you probably left 3 or 4 behind for the day. Was it worth it overall? And I guess if it wasn't, did the students appear to have fun? Students are going to like being out of, maybe their maths class or English class for the day. It doesn't necessarily mean they enjoyed your trip. So, it's really important to follow up and find out, was it all worthwhile? If it wasn't worthwhile, but they still had fun, again, reflection, can you make it more worthwhile the next year? Or would you make